The American Psychological Association reports that in Western cultures, 90% of people get married by the age of 50. Is that true? Well, once we master probability distributions, in particular here, the binomial distribution, we could go out and grab a random sample and figure out if maybe that's different for individuals in Orlando, for instance. Let X equal the number of people in a random sample of 4 that get married by the age of 50. Then draw the complete probability distribution of the binomial random variable X. Now there's a saying that, if I don't know if it's true or not, but I think it's very helpful for understanding how the binomial distribution allots probabilities to particular outcomes. But if you can't draw something, you don't understand it. I tend to agree with that with the binomial distribution in particular. Having you sketch the binomial distribution really allows for you to show off your knowledge of the way this thing is behaving. Because we have a discrete random variable, and we have not 4 possible outcomes, we have 5. Because X can equal, I'll just use baby X here, it can equal 0, or it can equal 1, or it can equal 2, or it can equal 3, or it can equal 4. And consider what each of these represent in the context of the problem. What does 0 mean? Well, 0 would mean that you encounter 4 Western culture people, whatever that is, and none of them got married by the age of 50. Now, what usually happens? Well, how many would we expect out of 4 to be married? And this is where the center really comes into play in terms of find the expected value of the random variable X. And it's always worth noting the following. X follows a binomial distribution where we have 4 and we have a 90% chance of success. That means that we have 4 individuals. 1, 2, stick figures need some help, but each one of them is a separate trial. So 90% for this person that they would be married by the age of 50, 90% for this person, 90% for this person, 90% for this person. So in terms of 0, it would, the outcome X equals 0, that would mean none of them. Wouldn't that be a bit weird? Well, yeah, because 90% do get married, according to the American Psychological Assembly of America. So out of these 4, how many would we expect on average? This, I think, is worth putting in blue because it's so important. It's just the mean of the probability distribution, which is n times p, and this is going to give you the answer to finding basically the entire graph, sketching it. If you multiply 0.9 times 4, that gives you 3.6. 3.6 humans in Western cultures per 4. So let's go to the graph. And we'll draw an x-axis. And the y-axis is the probability, or relative frequency. And then our possible x values are 0, 1, 2, 3, and 4. So where do the bulk of these probabilities lie? You can have 3.6 people married out of 4, but that's okay. It's the same thing as having Joe has 2 children, Jimmy has 3 children. On average, they have 2.5 children. But this 3.6 indicates that the bulk of the probabilities, like we'd expect, for every 4 people, remember it's out of like they're living for 50 years. That's where the probabilities are going to be. So we'll switch up the color here. And it's 3.6 is the mean, so you might expect that these are going to be really similar, but maybe a little bit favored toward the 4, and then it's going to teeter off. That's all I want here. And you could figure out the probabilities at each one of these towers. We know that this probability plus this probability plus this probability plus this probability plus this probability is going to equal 1. Because if you have 4 people, they're either going to be married 0 times by the age of 50, or 1, or 2, or 3, or 4. Notice how that plays directly into our hands of the additive rule. Right, and each one of these outcomes is mutually exclusive. Right, you can't be married 3 times and also 4 times at the same time. It doesn't make any sense. So this would be a very good picture here. I give myself a pat on the back.